Let's now take a look at the idea of probability. The basic understanding of probability is extremely important because much of what we'll be doing for the rest of the semester is actually based on the idea of probability. Later on, we'll be making many decisions regarding probabilities. Let's first talk about the learning objectives, like usual, and then I want to talk specifically about simulations. Now, learning objectives. Number one, we want to simulate simple experiments and compute the empirical probabilities. We want to compute both theoretical and empirical probabilities. We want to apply the rules of probability to compute probabilities, and compute probabilities based on odds, and odds based on probability. So that's a list of the four major areas I want to cover in these next several videos. Let's start with the idea of simulation. Now, simulation is actually extremely common for a lot of reasons. For one thing, it's much more efficient than actually running an experiment over and over and over again. If we can do a computer simulation, try to figure out what's going to happen, it's extremely efficient, extremely fast as compared to actually doing an experiment over and over, and it's extremely inexpensive as compared to actually running an experiment over and over again. Now, it's also very easy in a simulation to make minor changes and take a look and see what happens, what effect those changes have ultimately on the outcome. And in some situations, such as like a pilot, it's a lot better idea to let a pilot crash a simulator than to crash a real airplane, obviously. It's a lot cheaper, too. So let's take a look at a real simple simulation. What I want to do is I want to simulate tossing 2 coins in your calculator. Now, here's the idea. You don't know what the probability is when we start tossing 2 coins. You want to know the probability of getting no heads, 1 heads, or 2 heads. That's the only thing that could happen, right? When you flip 2 coins, they either both be tails, so there's no heads. One or the other could be a head, which means one's a head, the other's a tail, or they both could be heads. So I want to take a look and see what the probabilities are based on simulation of getting no heads, 1 heads, and 2 heads. So I'm going to create 3 lists, clear 3 lists in my calculator. I'm going to use L1, L2, and L3. I'm going to make sure those are all clear. And I'm going to code the data. Now, I'm not going to physically code it. It's just in my mind, I'm going to say, all right, when I see a 1, I'm going to let the number 1 represent a head and the 0 represent a tail. See, the calculator does not think very well in H's and T's. I couldn't say H is head, T is tail. Your calculator can't handle that. So I'm going to code it numerically. Choosing 1 and 0 makes a lot of sense. Because if I have a list of 1s and 0s, and I simply add up that list, what do I get? The number of 1s. So if I add up a list and 1 is a head, that would be the number of heads. Now I'm going to generate n random integers. N is my sample size. Is how many times I would outdo this. And I'm going to put them in L1 and L2. The idea is that L1 represents 1 coin, the result of 1 coin, 1s and 0s. Every time there's a 1 in L1, that represents a head in the simulation. A 0 is a tail. And in L2, that would represent the other coin. Every 1 in L2 would be a head for that second coin, and a 0 would be a tail. So rather than taking 2 coins and flipping them 50 times or 100 times each, and then recording what happens, I can let the calculator generate random numbers and do a simulation for me. Now, the next thing I'm going to do is I'm going to group them. I'll go to L3, and I'm going to add them together, L1 and L2. And that will give me the number of heads in that toss. Okay, I'm going to jump to the calculator now, and let's actually walk through that process. Now, I have L1, L2, and L3 already cleared. Let me stick some numbers in here. I'm going to just refresh quickly how to clear it if you don't remember. If I go up to L1, all the way to the top, so L1 is highlighted. See, L1 is highlighted. That says anything I'm about to do is going to have an effect on the entire list. Press the clear button. See, it cleared it down here. Now, if I hit enter, all these are going to go away. It erases it. It's gone. It's never coming back. Okay, so I'm going to quit. Go to Math. Move over to PRB. And then go down to option 5 on my calculator. Maybe slightly different on yours, depending on what version of calculator you're using. This is randint. Select it. Randint means random integer. Now, I have to have some syntax here. What I'm going to do is I'm going to tell it 0, comma 1, comma, the 0 is the lowest number that I want. 1 is the highest number that I want. These are random integers, so it's going to generate a bunch of 1s and 0s. If I wanted random numbers between 0 and 5, including 0 and 5, I would say 0, 5. Now, how many do I want? Let's do 50. I'm going to close it. Now, if I hit enter right now, it's going to generate 50 random numbers, zeros and ones. But I need to store it someplace. So come down here to the lower left part of your keyboard, and you see the stow key, S-T-O. Hit it, and what's going to happen is you get an arrow on your key or on your screen. The arrows is the way the calculator says I'm going to store it. Second 1 for L1. So this is going to generate 50 random ones and zeros and put an L1 for me. Hit enter. And there it is. Now I want to repeat this time put an L2. I can go back through the whole process or hit second enter and it brings up my last command. So I'll go back over to L1 and make it L2, second 2. So it's going to repeat the same command. This time store it in L2. So let's take a look at the editor. Stat, edit. See, this is my ones and zeros. If I add these up now, what this is saying is the 1 here in L1, this is my first coin, and the first toss on the first coin was a 1, so that means a head. The first toss on the second coin was a 0, that means it was a tail. 1 plus 0 is 1. I need a 1 right here. That says the first time that I tossed both coins, based on the simulation, I had 1 head. That's what that's saying. And likewise, the second one I had a tail on the first coin, a head on the second. The third toss ended up with actually both of them were heads, and so forth. So if I come over here and highlight L3, this says any operation, any command I give it right now will have an effect on the entire list. I'm going to simply type L1 plus L2, hit enter. It's going to add them up for me so I don't have to mess around. 1 and 0 is 1, 0 and 1 is 1, 1 and 1 is 2, and so forth. Now L3 has the combined results of L1 and L2. So these values tell me the number of heads. This 0 was said that both coins were tails. There were no heads. Now let's produce a graph of it. So if I go second, stat plot. Let's turn stat plot 1 on. And I'm going to make a bar graph. Whoops, I missed. There we go, histogram, bar graph. And I'm going to go to L3 and zoom 9. Now there's my bar graph. If I hit trace, so right here is a minimum of 0 to 0.28. In other words, this is all my zeros. I had 15 zeros. Out of 50 trials, I had 15 zeros. And let me see. Here's 0.85 to 1.1. That's all my ones. So out of 50 trials, I had 22 that were one head only. One head only. And the next one, I have 2 to 2.2. Those were both heads. Those are my 2s. There were 13. So let me see. Let me jot those numbers down. I got 13, 22, and 15. Okay? So 13, 22, and 15. That means we had 26%, 44%, and 50%. Oops, not 50, 30%. So, based on the simulation, if you didn't know anything about the probabilities of what's going to happen when you flip two coins, when you're interested in recording the number of heads, you would see there's 26% chance of getting no heads, which is the same as two tails, 44% chance of getting one head, and 30% chance of getting both heads. This is based on the simulation. Now we're going to talk about this in a little bit, the idea of empirical versus theoretical probabilities. This is actually an empirical probability. This is based on an experiment you actually did.